Hello, everybody, and welcome to this session called Introduction to Flutter. And this is the first time I'm doing a live stream like this, so I would like to extend also a big thanks to Developers Bay for helping me organize this. I hope it will all go well. So yeah, let's get started. Okay. The agenda for today, let's start that. It's an introduction to Flutter, but it's good to know what I'm going to talk about in detail. So first of all, we're going to have a brief overview of Flutter, high level, look at that. I'm going to give an introduction to the Dart programming language. And finally, I'm going to show the Flutter tools as well as a live coding of an app. And we'll end that with a question and answer session. Now, moving on. So a little bit about the timeline first about Flutter. So the first, before it was called Flutter, it was announced, we start with Dart. Dart, the programming language, was announced in 2011 by Google. It was developed by Google in-house as a way to fix the problems with developing for the web. The first release, 1.0 of Dart, was released in 2013. And in 2015, at the Dart Developer Summit, Google announced something called Sky, which was a project name for what would become Flutter. It was also later released 3 years later in 2018. Dart 2.0, which is the current version we're using of the programming language for Flutter, was released in 2018, just before Flutter 1.0 was released. The current release version is 1.12, and 1.17 is the latest beta version. So, Flutter is a declarative UI toolkit. It's not an operating system or anything like that. It's focused very much on being a toolkit for UI. And what does the declarative UI toolkit means? So, it's hard to talk about, explain that in a brief explanation like this, but I will show examples that will probably explain it more in detail. The way you can think about it is that the UI is declared. You declare the properties of the widgets instead of using the more imperative approach that other UI toolkits have used. In this example here, we have provided like the height and the padding and the margin for the container part of the widget here. And all these widgets in Flutter comes with what's called a sane default, which means that you don't need to provide all the properties. Most of them have defaults. So you can have an empty container. You don't have to provide all the details there. Now, it's also a UI toolkit that works by composable widgets. And this is as opposed to other UI frameworks you might be used to, where widgets keep extending more other widgets to create ever more complicated widgets. In Flutter, we have like very simple widgets that we compose together to create more advanced things. So that's also a difference from other UI toolkits. Flutter uses the Dart programming language. And Dart is a very simple language to learn. If you have used something like JavaScript, Java, C#, TypeScript, etc., Dart will be super simple for you to grasp. It's very similar to TypeScript today. It has a lot of the same functionality. And Dart also has some nice syntax features that make it very appropriate for this kind of declarative UI development that we want to achieve, which I will show in a moment. Underneath Dart, the program language, you'll find Skia, which is the graphics engine that runs the rendering for every Flutter app. This is the same graphics engine that is used inside Chrome, on Android, as well as the Fuchsia operating system from Google. Also, Flutter is cross-platform, but it's also cross-platform not just for the smartphone platforms like iOS and Android. It also works on the web. You can build directly to web applications, as well as desktop applications. The two latest one is kind of not ready for production yet, but they're getting there. So key selling points. This is important because, you know, why would you use this? And it's fun is probably my favorite of these. It's a great developer experience. It's so easy to get started. It's so easy to create really great looking stuff. The Dart programming language is just simple enough to use, so it doesn't make it hard for you. There might, of course, be some things that you like more than others, but and some things that you dislike with the language, of course. But overall, it's a very, very nice language to work with. The documentation for Flutter is very much up to date. They keep it up to date and they continuously update it, so you're never missing anything there. It's easy to find, it's easy to read. And of course, like as I said before, it's fun to write Flutter apps, which makes a lot of difference when you're developing a new application. So the Flutter system overview, you've probably seen a lot of these types of images before. I just thought I would mention it quickly. In the bottom, you have the platform specific stuff. On top of that, you find the engine written in C++. It handles all the communication to the native platform, whatever that is, Android, iOS, Chrome, etc. And on top of this engine, you find the Flutter framework entirely written in Dart. And at the it handles all like painting and gestures and composing widgets and stuff like that. But on top of the framework, you find the material design implementation for widgets, as well as Cupertino, that is the Apple guidelines for UI widgets. So you can have your application either look like the material design from Google or as Apple user interface guidelines. So you can choose yourself when you start implementing this. Another important detail about Flutter is about its widgets. There are stateful or stateless widgets. And the best explanation for this is the example I'm showing here. A regular text label doesn't need to track its own state. Therefore, it will be stateless. But a text field where your user inputs text needs to track the text that user entered. Therefore, it needs to be stateful. That's a very short explanation, and I will go into more details. You will see more examples of this later on. With that, we're moving away from the slides, and I'm going to go into some live demo. The first thing I'm going to do is to show you introduction to Flutter, or sorry, introduction to Dart. And I'm not going to go into every single detail of the Dart programming language. We don't have time for that. Instead, I'm going to focus on two parts. I'm going to focus on the optional and named parameters for functions and constructors, and why that is important, you'll see soon. And I'm also going to talk about the asynchronous programming in Dart, how that works. This will just be brief introductions. You just touch upon the topics just to give you like a better grasp when I'm going into the Flutter code. So what you see here is I'm using IntelliJ IDEA, but you could just as well use Visual Studio Code for editing Dart code or Flutter projects. What you see here is my main function, and of course I can do like the regular hello world. I can run that, and whoops, a little bit big there, and you see hello world is printed out there. That's great. So what I'm going to do now is I'm going to build a fake UI framework here. So we're going to start with something called, we're going to start with an abstract class that we call widget that has one single function called display. So an abstract class, or as would be in other languages, maybe you call it an interface. So the first thing we want to be able to display is the text. And I fix right there. My text will take a single string as its parameter. That. And this is how you define the most simplest case of constructors, where you assign the values to the properties of a class. So now I'm basically just going to say print text data. So when the display function is called, it will print the text like that. Now we're going to make a composable UI framework, so we want to be able to like set the background color or set a border, something like that. We'll define a class called container that extends widget as well. And this one will have a background color, it can be an integer, a border color, it's an integer, and a border width. Also, the widget, this container widget needs to contain something, so it will have a single widget called a child. We will also need to implement the display function. What we do there is we say print container border width. So it just prints out the properties we set on that one. And then it calls child.display. Now we need to add this to the constructor as well. So we'll create a constructor for all those fields like this. But we don't want all of these parameters, all these properties to be mandatory. You should just set the ones you want to. So what we do here, we wrap all of these parameters inside the curly braces. So any constructor function that has curly braces around these parameters makes that parameter optional. But not only optional, it also makes it a named parameter, as I will show you soon. Now, since we might always want to have a background color, which means that we can set default value for an optional parameter. In this case, we set default parameters for all of these, the first 3 ones. But we don't set it for the last one, which means it could be null. And the way to handle nullability in Dart is similar to other languages. We basically use question marks before the dot. So as long as a child is not null, then call display. Now, finally, we want to have a widget that can contain many children, like a list. So we call that one a column. And that one will have a list of widgets called children. Create the function here. And what this one would say is print column with children. Basically printing out how many children it has. There you also see how string interpolation works. If you use a curly braces in the string interpolation, you can write complex expression there. If you just write a value, you use the following without the curly braces. So we'll add this, the children. We also make that one optional. And then again, then we just iterate over all the say child display. Now we want to deal with the fact that it could be null, so we give it empty. An empty array. And we do that like that. So this is a shorthand for declaring an array, and this is a shorthand for declaring an array of certain, or a list, sorry, a list of certain type. And because this is the default parameter, it needs to be a constant. So we say const. So if we don't provide the children parameters, it will be an empty list. So it will just, this loop will just exit immediately. Okay, so now we built up our UI framework for displaying text with possible background. So we go back into the main application. I say a great variable called my app, which is starts with a column. And here I'll say children here. One is a container where I say the background color is child, text is red. That 3 times. Let me change this a little bit. Basically 3 text there. And then finally I say my app display. So you can of course run this and it will print out the result like that. Nothing strange here. This is probably something you could come up with yourself, but I wanted to do this to explain to you why Dart makes such a great choice for a declarative UI toolkit. So what we do here is that we say we just give the parameters we want. Of course, the column only had one property, so that one goes through. But in each container here, I just define the parameters I need. And this is exactly how you write Flutter apps, basically. This is what you will do a lot, this type of programming. And that was the first part of introduction to Dart. You'll see more of this in a moment. Now I'm going to show you asynchronous programming because it's important to know that that works as well. So I'm not going to go into all the details, but let's just say that we have a function called load data that might fetch data from the backend and returns a string. I will use the convenience function called delayed. That will delay for 3 seconds and then return. Oops, that should be single quoted there. So now if I would do result like that, and we run this, what you get is instance of future. Instance of and the type of the class is the default print when you print the class, or print an object. So in order to do this, if you're used to how futures work, is basically to say then value, oops, value. And if I run this now, it waits for 3 seconds and prints hello world. Nothing strange. However, we don't want to use this notation, this then syntax. It creates the callback hell and it's hard to follow. So what we do instead is that we convert our function, our main function here, to an async function. Once we do this async, we'll use the await keyword. And now we can write our asynchronous code in the same way as we do regular synchronous code, sort of just using await. That will then make this function pause until the result is ready. So run this one again, and it will just wait for 3 seconds before it prints hello world. So async await exists in many other programming languages. You have probably used that one before if you use like JavaScript or C# or Kotlin or something like that. But it's good to know that this also exists in Dart, and it's what's used to do all the asynchronous operations, loading data from network, etc. So you never work with threads in Dart. You only use futures or streams, which will be the reactive streams concept. But it all builds upon this. Okay, with that, we're going to move on to the Flutter Toolkit and the SDK. And I'm just going to do this very quickly here. Let's see if we can get this a little bit larger. So I'll start by creating a directory, my first Flutter app. And the way you create a Flutter app is basically by using the Flutter command line. You can use, of course, the ID tool as well, but I think it's nice to use the Flutter command line for many of the things. We'll say Flutter create. You give a package name or an organization. In my case, then I will use my own domain. Flutter app. And you'll use a project name. And directory you want to create it in. So you start generating all of this code here, and waiting for it to finish. It seems to have, there you go. It also checks if everything is okay. I got a couple of IDs here, so I'm using IntelliJ IDEA for all my Flutter coding, but I can also use Visual Studio Code. And now I can do Flutter. Flutter run, which will use the first available simulator. So it starts building. I should probably have done this in advance, but there you go. It installs the app and it launches it. And that one works. Now I can quit this one, and instead of running it on a simulator, on the iOS simulator, I can choose to run the exact same app, no code change, in Chrome. Of course, as I said before, running the web apps is currently in beta, so it's not ready for production, but it does work. I'm not going to go into all the details about Flutter for the web. That's a completely different session, but as you see, we have the same UI here. The Flutter Toolkit provides like hot reload, and so you just make small UI changes and you just press save and everything will reload automatically for you, which is super nice when you're iterating the code for your UI. Okay, now we're going to go into the more interesting stuff. I'm going to write and live code an entire app, and I'm hoping this will work. So I have cheated and created some of it in advance, and it is a very simple to-do application. So launching this. As I said, I'm using IntelliJ IDEA. If you like Visual Studio Code, I would recommend you to use that one. I actually think that the plugins for Visual Studio Code is probably a little bit better. That seems to be the choice, but I'm so used to using IntelliJ, so there you go. Okay, so here is my to-do application. Currently, it just lists the to-dos I had in my database, and there's no action for this. I have just added a print, a small text print here that prints in the console whenever I press the add button, and clicking on the items doesn't do anything. So let's go and look at the code. The way you write a Flutter app is you have a main function, regular main function, and in that one you call run app. Now this is an alternative way of writing functions. When you have a single expression, you can just do a one-liner like this. So run app is an entry point into starting the Flutter engine, basically. And that one takes a widget. And in this case, I have my app, which is extending stateless widget, which is what you usually do for the top widget at least. This one has a single method called build, which will build all its children, all the child widgets. It gets context for the build, for building these widgets passed to it here. And the first child is called multi-provider. The multi-provider is basically the way we set up any data models or repositories or APIs, etc., that we need to access during here. So in this case, I have a single model called to-do model. And to-do model looks like this. I had this one prepared before. It's basically just an interface to SQLite database for adding and removing and retrieving all the to-dos here in this. I'm not going to go into details here. All of this code will be shared. I will have it up on my, I already have it up on my GitHub. But you can go and check that one later. Enough about this one. The nice thing here is that it will automatically notify any listeners, anyone who wants to fetches all the to-dos will be automatically notified when nodes are updated. So the setup for that happens here. And then I want to use material design. So I have a material app. I give it a title. I configure the theme here. And then I say, okay, what's the home? What's the start screen for this one? It's the to-do home widget. And navigating to the to-do home widget, we get to this one. It's using the scaffold widget, which is another material design component in the Flutter framework. It provides some out-of-the-box stuff that we usually do when we use material design, like the app bar. You can add a floating action button, and the whole body is defined in special. So like these three, but you can also define a bottom sheet or bottom navigation, etc. And this list view here, what I do there is that I go to I fetch my to-do model, as I do here. Let's go to that one. I fetch my to-do model, and I iterate through all the items, and I convert them using the map operator to a to-do list item. And a to-do list item is another stateless widget, which receives a to-do item in its constructor. And the only thing it does is display text. So the first thing we're going to do is going to make this list here look a little bit better. So we start by adding some padding. And this is a nice feature of the development tools for Flutter. It's existing in Visual Studio as well. So just bring up the context menu when you're standing on a widget, and you get this menu. And we add a padding. I press save, and immediately that fixes it. Now I would like actually to have all of these in separate cards. So I will wrap this as a widget, regular card. It's material design card widget. Let's press save there. You see, it might be hard to see the details here because the shadow is a little bit blurred probably. But now we've got cards here, but they're going all the way to the edge. So I want to add another padding. And there I got it. A little bit too much padding between these. So what I will do, I will change this one to use a different function. I will say I want 8 on the side, 4, 8, and 4. Maybe change that to 2. And let's make these a little bit bigger. So there we go. Now nothing happens when I click these. And not only do I want something to happen when I click them, not only do I want something to happen once I click, I also want to have this splash effect that's common material design. And I'll add what's called an inkwell. That will provide that effect for me. And I say that we tap this one, call this function. I leave it empty for now, or I just do it on let's see, title. Bring up the run menu here so you see. Save. Oops, that was wrong. There we go. There. And if I click now, you see there is an effect happening and it prints out something, but the effect is happening on the wrong level. That's because I need the inkwell to be inside the card and not around the card. And now comes the fancy part of the Flutter UI, or the toolkit, so let's say the features provided by the IDE or Studio Code. Swap this with the child, and it automatically fixes that for you. I save this one now, and I get the nice effect. Now, what I want to do here when this function is called is I want to navigate to a new screen. And the way to do that is to use a navigator, and you pass a material page route to the navigator. So you push a new screen to it. And that one takes a builder function. That one. And I'll return the details, and I say, give it the item. I save here. And now when I press this one, I'm coming to a new screen. So let's go in and fix this screen right away. This screen, since this will be the screen that will edit the details, we want to see the details, but we also want to edit them. It needs to be stateful because it's going to keep track of the text you edit. So the stateful widget works like this. It has a single function called create state. And the create state, here you can store the stateful parameters or properties. And the way Flutter deals with private public is by using underscore on the variable names. And here I have 2 text editing controllers, which you probably hear by the name what it means. It takes care of text editing input. We initialize them in the init state, and later we need to dispose of them as well. So this is why you prefer to have stateless widgets, because they're much simpler. But when you need to use this, it's not super hard. You got all the callback methods ready for initialization and for disposing. And the build function here will return the UI. And currently we only have centered text here. So what I want to do here, I want to have a column where I have a text field. Oops. I want to have a text field. where the first controller is my title controller, and then I have another text field, description controller. I save this one now, and it works right away. And the reason for that is that these controllers, they were initialized with what was past this constructor. I'll go back here and click here. Everything works fine. But go in here, that doesn't look really great. So what we want to do here is we want to decorate this. Input decoration. We want a border around it. Let's see what happens when we have the default one. And we'll do the same for this one. We got two borders. We need to add some padding here. So we just do like that. And we got that. We'll leave those for now. There are more stuff we could add here. We could, for instance, let's actually add one more thing here. Label. We want a label for this when it's empty. In this case, it's title. And we want to align that as a hint. You'll see what I mean when we add new items. So, description. Now, except for these text fields, input text, we also want two buttons. I will use a utility function here called raise button. Give it an empty function to start with. We give it an icon. So we have one button. Clone that one. We say change this one to be delete. And we got buttons there. Well, this doesn't look great. We want to have the buttons next to each other. So I will wrap this in a row. Move this one in. And then we got it there. Now, not perfect. I would prefer having it on the right side. So I say main axis alignment. Put it on the end. And again, padding is good. Let's do that. And looking a little bit better. Functions don't do anything at the moment. So I'll start here. What we need to fetch our model. Model. And then I want to say, oh, we actually didn't need to that. I had it already. We have a save item and we have a delete item functions. I want to call those. So when press save here, save item, widget, ToDo item. And in the delete case, I'll say delete item. And these will basically just fetch the provider, set the properties, call save, and pop the stack of the navigation. Delete will just call remove and then pop the stack of the navigation. One thing though, we don't want the delete button here to exist, to be enabled if this is a new item, because that wouldn't make sense. So what I will do, I will mark that one, and I will extract that, delete action. And I will say that when widget ToDo item has an ID that is not null, then it's okay to call that one. Otherwise, the delete action should also be null. And the reason to do that is that the enable disable state on buttons and many other things in Flutter is based on whether the callback function is set or not. So in this case, the item details has an ID. So when I press delete here, it will disappear. We will just press delete and it disappears there. And we'll check that the save also works. Yes, it works. Now we need to add this one. So we will go back to our home widget. And here I did on press. I just did a print statement. Again, navigator, push, context, material page route, a builder. We're returning to do details, but with a newly created to-do item, where all I do is set the created date now. So now when I press this one, we come back to the details scene here, but the delete button is disabled, and I can say another note, some description, and save, and it works. And that was basically all I had to show for creating this ToDo app. We implemented the UI, made it look a little bit prettier, added actions and navigation between screens, and it all works perfectly well, and it's super easy to build. So with that, I will switch over to my final slide here. And I will leave this one up. And I think I can go and start some questions. It has been 45 minutes, so we have a little bit time for questions. They're starting to appear here. Is there functionality in Flutter to handle audio from the phone, like recording and replaying sound? Yes, so this is typical questions, like if I want to do this advanced thing, like that depends on hardware on the device. Yeah, there are packages for plugins for doing most of the stuff. The quality varies depending on what you want to do. The quality varies depending on which platform you're targeting. So sometimes it works better on iOS, sometimes it works better on Android. So the plugin repository is called pub.dev, and here you can basically search audio recording, Flutter audio recorder, etc., etc. So you check these, you can find information, you can just try them out. It comes with instructions on how to integrate it into your project. Hope that answered your question. Another question about React Native. If I have experience from React Native, what's the pros and cons with Dart, Flutter versus React Native? So I wouldn't call it the pros and cons so much, but React Native started for the web and then started targeting Android and iOS. So when they made React Native, they started with React and then went React Native. Flutter did the opposite. So it started targeting the smartphone platforms. I would say the main advantage is that the performance of Flutter apps is really, really good by default. It's really hard to make your Flutter apps stutter and lag. So they have a way of rendering the UI that is highly optimized. So for very visual applications, I would say Flutter is much, much better. Now React Native is much more mature ecosystems. So integration to things like Bluetooth or audio recording or other advanced things are probably a little bit better in the React Native. But Flutter is catching up fast. It's moving really quickly. How does Flutter compare to other cross-platforms? Well, I compared it with React Native. React Native also declarative UI framework, sort of. Xamarin is the C# .NET based one, and that's like more of the old school imperative programming with widgets. So it's about the style of programming. Again, also I would say Flutter is probably better performance than Xamarin out of the box. I also have a feeling that Xamarin has been lagging behind lately, so I would probably avoid it unless you have a good reason, like you only have C# developers or you have a lot of C# code you want to reuse. Automatic testing, yes, there, let's check the documentation for that. So this is a flutter.dev, that's the main site for it. And what you do here is you got this nice testing documentation. It's super simple. You can do unit testing, just regular unit testing works as any other unit testing framework. And you can do widget testing, which is super simple to do. It's basically you write the test very similar to how you write a unit test. You just pump the widget, so you make sure that it renders and the state updates, etc. Manually, and you have full control of everything. It's simple to write tests. So they made sure that works from out of the box. Yeah, I like this table that they provided here for this as well. Is Flutter usable for backend programming? Well, the question is more, is Dart useful for backend programming? Yes, of course it is. Dart can target both native code or JavaScript, so you could like target Node.js backends as well. Declarative structure can be very cluttered. How do you organize your widgets? Basically, you just extract a new class. If you have something you reuse, you extract the class and create a new stateless widget that just composes what you want to. You can of course just use utility functions and stuff like that. So it doesn't have to get cluttered, and you can declutter it or refactor it as you move ahead. So say maybe you implement a UI once and then you realize you need that one. You just select that entire part of the tree and extract it to a new class. Is there anything similar to Expo for distributing a beta version of a Flutter app while developing? Well, Flutter apps targets like iOS and Android. So you use the same tools as you would for developing iOS or Android apps, like TestFlight, what is it called, the Firebase version of that one. All of these beta distribution things works just in the same way. Screen rotation, yes, that works. You can tweak it. You can query it. There's utilities for querying the size of the screen, or the state of the screen, or rotation, etc. So you can handle screen rotation as well. Do you think that Google will introduce a 3D engine for Flutter? No, I don't think so. That's because Skia, the rendering engine, is not really optimized for 3D. Of course, they might like provide you with an OpenGL widget that would work kind of like the custom painter works in Flutter. So it might be that they provide something on top, but I don't see that they would do it out of the box here, no. Dart versus Kotlin. Well, I come from the Android camp originally. I like Kotlin more, but I would say that Dart is today easier to write this declarative UI. Is Flutter joinable with Kotlin? Well, that's been a discussion in the Android community for a long time. Can we get like this Kotlin version of Flutter? Well, Google is working on the Compose, which is their version. But no, you can't use Kotlin to write Flutter apps, unfortunately. Okay. I think I got all the questions. Anything more? Should Android devs migrate to Flutter? I don't think you should migrate to Flutter just because. If your app is in Kotlin already, there's no reason to migrate. If you're going to build a new app, and you got limited resources, limited amount of developers, Flutter is a great choice. Anyone can get started with Flutter really quickly, regardless what your previous background is. Is it easy to write your own Dart integration with device hardware? Yeah, well, let's say you have they come out with a new feature on both iOS and Android that's not in the the Flutter SDK from start, you have to write your own integration. So you have to write it both in Swift and in Kotlin for each of these platforms if you want to support the smartphones. Easy is a relative term. Everything is asynchronously. So you have to think about that. You can't make synchronous calls, which can be a little bit tricky depending on what you want to do. Maintaining app data. So yes, that's the provider. Provider is the tool you use for all of this. Think of provider like a view model. That's one way to translate it. It's not exactly the same thing, but it's similar. Any specific use case not to use Flutter? I would say today, more advanced use of hardware. If you're gonna do like a lot of Bluetooth integration, like BLE, if you need camera, like high control of the camera, like you're doing a camera application, probably not use Flutter. Yeah, biometrics, security, etc. So all of those might be a reason not to go with Flutter. I'm not saying that you can't, but it depends on your use case. It might make it harder. What I've heard from others is that Bluetooth is especially hard to get right. So when using the Cupertino theme you mentioned, does it look like iOS even on Android then? Yes, it does. So how would you do that? Well, the Cupertino widget set is a little bit different from the one on material design. So of course you can't just swap that widget and leave the rest, the ones underneath as is. But again, if you're writing a cross-platform app, you probably want the same look and feel on both platforms. Sorry. So yeah, you have to choose. You probably choose one. You could probably write one that uses Cupertino on one platform and not on the other. So animations, drag and drop, similar interactive features. Flutter has a really good animation framework. I haven't shown you any of that yet, but it's super simple to add animations. It's super simple to do really advanced animations that would be hard on other platforms. Yeah. I hope that answered it. It's there. You can find a lot of really cool examples. If you would go back to my slide here, if you search for Interact, Flutter Interact was an event they had last year. They have recordings here, and there are a bunch of sessions here that show some really, really cool animations and like UIs they created in Flutter. There is also from G. Skinner, there is a bunch of selected vignettes that he's done especially for Flutter, which looks really cool. These are great examples to show what you can do in Flutter. And when you check this out, you see that the amount of code is actually not that much. So, okay, it's been an hour. I think I'm gonna call it there. Thank you, everyone, for joining. Hope you had a great time and learned something new. As I said before, this will be recorded. I will we'll make sure you send out information to the emails we provided. And stay safe.